Welcome back. In this video, we're going to go over the two-sample t-test, which is the first hypothesis test that we're covering in our class. We'll start with the definition of a two-sample t-test, and then we'll go over the use of a two-sample t-test, when it's useful, and then we'll go over a few examples of running a two-sample t-test. So a two-sample t-test is a hypothesis test that's used to decide if there's a difference between the means of two populations, and it's called a two-sample t-test because a person calculates a t-score during a two-sample t-test. We'll get to that later. And here are a couple possible situations in which a person could run a two-sample t-test. So if a person wanted to know if the mean income of college graduates is higher than the mean income of non-college graduates, the person could run a two-sample t-test because in this situation, the person wants to know if the mean of one population is different than the mean of another population, and in that situation, a two-sample t-test can be used to reach a conclusion. Another possible situation is if a person wanted to know if the mean IQ of people who went to preschool is higher than the mean IQ of people who didn't go to preschool. If a person was collecting data to try to answer that question, the person could run a two-sample t-test on his or her data set to arrive at the conclusion, because the person wants to know if the mean of one population is different than the mean of another population. So anytime a person is in a situation in which the person wants to know if there's a difference between the means of two populations, and the person is gathering data, the person can run a two-sample t-test on the data set and reach a conclusion about whether there appears to be a difference between the means of the two populations. And just like in any hypothesis test, there are two competing possibilities that are being considered in a two-sample t-test. And just like in any hypothesis test, the two possibilities are called the null and alternative, and their symbols are H0 and H1. In the last video, which was Introduction to Hypothesis Testing, I said that the null hypothesis is a possibility that nothing is happening except for chance, and the alternative is a possibility that something is happening. So that, in general, that's what these two possibilities are. But when you're focusing on a specific hypothesis test, like a two-sample t-test, the null and alternative will have more specific wording. So in the context of a two-sample t-test, the null hypothesis is a possibility that the population means are equal, that there's no difference between the means of the two populations, and the alternative hypothesis is a possibility that the population means are not equal, that there is a difference between the means of the two populations. So basically, the null hypothesis is saying that nothing is happening, and the alternative is saying that something is happening. But in the context of a two-sample t-test, nothing is happening means no difference between the two populations, and something is happening means there is a difference between the means of the two populations. So to run a two-sample t-test, you need to meet these requirements. So you need to have random sampling. You need to do random sampling from two populations, actually, because when you're interested in the means of two populations, you have to sample both of those populations. So it's random sampling from two populations, and either the two populations have to both be a normal distribution, or the samples have to be 30 or larger. So this is really the same checklist that we had for confidence interval of a mean, but we're extending it to two populations. So now it's two populations that have to be randomly sampled, and two populations that either have to be normal or be sampled 30 or larger. And if you don't meet these requirements, what will happen is either a type 1 error or a type 2 error will become more likely. Basically, an incorrect conclusion will be more likely, and basically the test will be less reliable. And the loss of reliability, or the amount of reliability that's lost, depends on how severely these are violated. So if the sample size is 29, it's actually not that big of a deal. But if the sample is, let's say, 5, and the population is not normal, then that would be a problem. And just to go back to my last video, if you need a review of type 1 and type 2 error. And these are the steps of a two-sample t-test. There's actually two different ways to run a two-sample t-test. There's the critical value method and the p-value method. We'll cover the critical value method first, and these are the steps for running it. So first you set up your HO and H1. You state the two possibilities that are being considered, the null and alternative. Then you randomly sample from two populations. You randomly sample from the two populations that you're interested in. So if I'm interested if the mean IQ of people who went to preschool is different than the mean IQ of people who didn't go to preschool, I would need a random sample of people who went to preschool and a separate random sample of people who didn't go to preschool. And I would have to record the IQs of everyone in sample 1 and the IQs of everyone in sample 2 of all of my participants. So you randomly sample from two populations, you collect data from your two samples, then you use all of that data to calculate a t-score. So you only calculate one t-score, and you calculate it with data from both samples. Basically, you calculate it with data from all participants. Then after you calculate the t-score is what leads you to your decision to either reject or retain the null hypothesis. And you have to look up the critical value, which is the value that it's the number that the t-score has to reach to reject the null hypothesis. So if you go back to my last video, you'll see that I mentioned the idea of a test statistic, and I said if the test statistic reaches the critical value or higher, you reject the null hypothesis, and if it doesn't reach the critical value, you retain the null hypothesis. In a two-sample t-test, the test statistic is the t-score, so the t-score the t-score is what you compare to the critical value, and if the t-score reaches the critical value, reject. If it doesn't reach, retain. And after that, you reach your decision, and you also reach a final conclusion that fits into the context of the question you're trying to answer. For example, if I'm interested if the mean IQ of people who went to preschool is different than the mean IQ of people who didn't go to preschool, I would reach a conclusion in the context of that situation. I would either conclude that one population, I would either conclude that I'm confident that one population is higher in IQ, or I would say that there's not enough evidence for a difference between the two populations. And there are three possible outcomes of a two-sample t-test, because in a two-sample t-test, you actually have two critical values, because you look up the critical value in a table called the t-table, and you actually use the critical value and its opposite. So let's say you look up the critical value and it comes out to 2.3. Well, then in your t-test, you would actually use 2.3 and negative 2.3, both of them. Or let's say you look up the critical value and it comes out to 3.1. Well, then in your test, you would have to use 3.1 and negative 3.1. So you have the critical value and its opposite. And I call these the negative critical value and the positive critical value. So the positive critical value is what comes from the t-table, the positive number, and the negative critical value is just the opposite with a negative sign in front. And if the t-score reaches the negative critical value, then you reject the null hypothesis and conclude that the mean of population 1 is lower than the mean of population 2. That's your inference. If the t-score reaches the positive critical value, you have the opposite inference. So you reject the null hypothesis and you conclude that the mean of population 1 is higher than the mean of population 2. And if the t-score doesn't reach either critical value, you retain the null hypothesis, and you just give the null the benefit of the doubt, and you say there isn't strong enough evidence to confidently say that these populations are different. So if the t-score reaches either critical value, you reject the null hypothesis because, like I said, the critical value is the cutoff point for rejecting the null hypothesis. But the specific direction of the conclusion depends on which critical value is reached. So if you write out a number line and you mark off the negative critical value and the positive critical value, it'll divide the number line into 3 areas. So you'll have an area at the left called the negative rejection region, which starts at the negative critical value. You'll have an area at the right end starting at the positive critical value called the positive rejection region. And then you'll have the area between the 2 critical values called the non-rejection region, and that's where you retain the null hypothesis. And so this is all I wanted to cover in this video. In the next part of this video, we'll get into the calculation of the t-score, and we'll go over a few examples of running a 2-sample t-test.